Hi, good afternoon everybody. Welcome to another episode of Math with Tinker's Cap. My name is Mr. Tam. Okay, today we're going to go through a topic in vectors, which is usually taught in secondary 4. Okay, this topic is actually taught in E-Math, but in subsequent years as you progress into H2 Math, you will still continue to see vectors. So a strong foundation in the concept of vectors is very important. Alright, okay, let's take a look at this example here and see how we can add two vectors and represent it on the diagram itself. Alright, okay, we all know that vectors basically is defined as a quantity that has the direction as well, magnitude and direction. Alright, so in this case, I'm given position vectors relative to O. So I have OP equals to 2, 1, okay, expressed as a column vector, and OQ equals to 3, 1. Okay, in this case, you're asked to find PQ, alright? So using the laws of addition of vectors, okay, the triangular addition of vectors, okay, my starting point is P and my ending point is Q. So I have PO plus OQ, alright? Okay, and since I have OP, I'm going to express PO in terms of OP, and it is in the negative direction. So I'm going to have minus OP plus OQ. Okay, some students may prefer to use OQ minus OP, and that's fine as well. Okay, so now I'm going to put in the column vectors, right? Okay, I have minus 2, 1 plus 3, 1. Okay, and when I evaluate it, okay, it is similar to adding a 2 by 1 matrix, right? Where I have minus 2 plus 3, minus 1 plus 1, and I have 1, 0. Okay, so that is the vector PQ, 1, 0. And what does it mean? Alright, so when we express it in terms of 1, 0 column vector, what we are saying is PQ is actually a position vector, right, with position 1, 0. Okay, let's see how is it represented on a coordinate Cartesian graph. Alright. Okay, so if, let's say we're going to represent OP, okay, 2, 1. So in terms of P, I have 2, 1 here, 2, 1. So that's 2, 1, right? That's point P, right? And I have Q, 3, 1, 3, 1. All right. Okay, so I have OP here, this is OP, and this is OQ. Alright, so together, okay, I want to find vector PQ, and where's PQ? Okay, PQ is over here. I'm going to represent it using a red line here so that you can see it for yourself. Okay, PQ is here, PQ. So using the triangle laws of addition, my PQ, right, I have OP plus PQ. OP plus PQ equals to OQ. Okay, notice the triangle has been closed. OP, PQ, and OQ. So I actually closed the loop. Okay, this is what is implied by the triangular laws of addition, right? So in other words, my PQ, okay, would be equals to OQ minus OP, which is exactly the same as what we have done here. OQ minus OP. Alright? So now, the point over here is 1, 0, right? So in other words, what we're saying is PQ, if we're going to move the vector of PQ back to the origin, okay, it will be represented by 1, 0 here. 1, okay? Probably I've not drawn it to scale. Okay, 1. So this vector, okay, is the same as my vector PQ. And I can say that they are the same because the direction is the same, parallel to each other, and the magnitude is the same. Notice that the magnitude here is 1 unit, and the magnitude here is 1 unit as well. And therefore, PQ as 1, 0 is actually a vector that is placed with the starting point as O. Alright, I hope that this lesson, through this lesson, you have understood better the concept of vectors and how PQ can be represented on a Cartesian graph. Right? If you like this lesson, I'd like to learn more about our lesson, okay, please click the link below and join us in our class. I'd like to see you on the other side.